Welcome to the Unit 7 mini lesson 7.2, moving in a direction. In this lesson, you're going to use the repeat loop tool to create movement by making a sprite move around the screen. I actually like this lesson when I teach it because it's kind of cool to actually get to see something move around. For new programmers, it's always pretty cool to be able to program something and see it move across the screen. So I like doing these kind of things. Also, we're also going to learn how the movement of sprites based upon direction. So you'll learn how to point the sprites in multiple directions, and then how to change the directions for the sprites, and also how to estimate the speed of a sprite. Okay, estimating the speed, we're just going to estimate. We could get in some hard math and actually calculate the speed. You can get as complex as you want to with any type of algorithm, calculating speed or momentum or force or acceleration and all those type of things. All those capabilities are within your grasp for Scratch, but for right now we're just going to get the basic understanding of estimating the speed, because we're just trying to keep this real simple so we can go out there and have a good time. Okay, so first things first, the motion and the movement of sprites. So your sprites all face a direction, even if it's a circular shape like this soccer ball, okay? The soccer ball, or this one's called runner 2, just by chance I'm over here, okay? It has a direction that it faces, and it's measured by degrees. And by definition, a degree of an angle is a unit of measurement to know which direction an object is pointing in our X and Y grid. And then the angle is the amount of turn for your sprite. So if you go over here and if you were to click on the letter I for this soccer ball and come over here, or football if you will, you'll notice that its direction that's facing is up by the blue line facing up, and it's at 0 degrees. So technically this sprite is facing upward because the information we got from the sprite by clicking on this letter I right here tells us that it's facing up. Also note that its rotation style is 360 degrees. That means this ball can turn with its image 360 degrees. Okay, and that also means that this direction can go 360 degrees. Now, I think I just mentioned all that. I didn't read my notes. I'm just kind of going by my memory here. Make sure you know the difference between 360 degrees of rotation and 180 degrees and then 0 degrees. And the key term right here is that these are for the image, okay? These are for the image. You may have this one selected right here where it allows 0 degrees of rotation. The image won't change its direction. However, the sprite can still change which direction it's facing, which seems weird because you're thinking, well, the image should face the same way as the sprite that it's pointing. And logically, yes, but you have to understand too, that this is a computer program. It's not necessarily following the rules of nature here or physics. So even though it's pointing a different direction than the actual image is facing, and the image can't turn, but the direction that it can move can still turn. Alright, next, whenever we start moving with the motion of our sprites, we're going to use this little block here called move 10 steps. If you put this in your program and try running it a few times, you won't get very good results, because what you have to do is you have to repeat this motion over and over again to give the appearance that the object is actually moving at a particular rate. Okay, so this block will move it as the sprite a number of units on the XY grid. Right here it says move 10 steps. You can think of this, that it's going to move the sprite essentially 10 pixels across the number of units on the stage. And if that's going in the x-axis, it's going to be 10 units to the right on the x-axis. If it's y, then it's going to be on the y. But the good news about this is it doesn't limit you to just x-y axis. It'll move 10 steps in the direction of your sprite. So if I go back to the previous slide right here, this ball, it's facing upwards. If I was to tell it to move 10 steps, the ball would actually move upward 10 steps, okay? Because that's the direction it's facing. Now right here, a loop, it's a code that repeats itself over and over again. You probably think of your heart and your lungs. Those operate on a loop. They keep repeating themselves over and over and over again, okay? And you could think of those as an infinite loop. They don't ever stop, hopefully. And inside our code, we have a loop that just keeps repeating itself over and over and over again, okay? And we use this loop to to create the sensation that the block is actually, or excuse me, that the sprite is actually moving. It gives it a little bit of fluidity when it goes across the screen. Now we can use the repeat blocks in the move blocks in different combinations to create movements that go at different rates or speed. For example, this sprite, if it had this block right here, this block would repeat itself 4 times and it would move 120 steps. Okay, that would be very fast because every time the computer went through this 4 times, it would move 120 steps, which is a total of 480 units. Right over here, the computer would have to go through this 120 times, moving at 4 steps per a loop to go 480 units. This is a little bit slower than this one right over here, okay, because it has to go through this code 120 times, moving at 4 steps per loop to get to the end result as this one. And then over here, this one would have to go 480 times, 1 step per a loop to get to 480. So this would move the slowest. Okay, that just gives you an idea of how the speed would operate. And if you want to, go ahead and pause the video and stick those inside Scratch and view the results for yourself and see what happens. And you'll notice right up here I got this one with this loop repeating 48 times, moving 10 steps, and that would go a total of 480 units. Now it's up to you to figure out which one would go the fastest between all 4 of these. For those of you that are new to speed, let's quickly talk about that. We're not going to get a lot of calculations. Okay, so speed is the rate of movement for an object calculated by distance divided by time. So the amount of distance that you move in a particular amount of time will determine your speed, which is your rate of movement. Okay, the term measurement, whenever we use that, is talking about a number that shows the amount of something. In our case, the measurement for our objects as they move across the screen is how many basically how many little points it moves across on that XY axis, how far it moves across there. You could almost say it's a pixel unit as it moves across the screen. So that's going to be our measurement, how far it moves at a particular rate across the screen. And then the clock cycles, this is important. Okay, this is the measurement of time that it takes a computer to complete a set of instructions. So you may have a loop on your screen, or a repeat loop with moving a certain number of steps. You may have a very slow computer, and it may move slower than it would, say, on a computer that's very quick that was able to execute that program at a much faster rate. So just because it's something that you calculated speed-wise doesn't necessarily hold true once it runs on different machines. And there's a lot of game engines that can help you compensate for that difference. Scratch, we don't have that ability because we're just learning how to program. So it's something to keep in mind, all these different items whenever we're looking at speed of an object, especially if you take your program, go run it on somebody else's machine, and it's running a lot faster and things aren't working exactly the same. It could be because the clock cycle and the measurements are a little bit different. Okay, so right here we also mentioned that we use the wait block right here. We use the wait block to help control and slow things down so we can actually see the movement of the object as it goes across the screen. It just gives us a little bit of ability to help keep things under control and stay organized. Okay, so to make a sprite go faster, there's a few different ways. You can increase the amount of units the sprite moves across the screen each time it is repeated. You can see this here in example A. Okay, so this sprite technically moves 10 steps, repeating 48 times. Then right here we speed it up by increasing the number of steps that it moves each time this repeats. Okay, so that increases the speed right there. Another way, if you look at B, we can slow it down. We slow it down by decreasing the number of steps that the sprite moves with each loop. We're still repeating 48 times between these two, but this one now is taking 5 steps per loop as opposed to this one, which was taking 10 steps per loop. And you can also slow things down by putting in a wait block right here. For example, on C, this sprite's moving 10 steps in a loop of 48 times. Down here, the repeat loop is 48 times. We're still moving 10 steps, but we put this wait right here. And that causes the program to slow down a little bit, by adding some extra time into the calculation of the movement. Now we're ready to program. I'm going to go ahead and pull up the completed program so you can see what that looks like. It's pretty simplistic, however, it's good to see these concepts in action to start building out that groundwork. So I'm going to pause the video and switch over to Scratch so you can see the end product of the file called Moving in a Direction. So here's the file. We only have one sprite, and then we have the stage. There's nothing on the stage. You can change the backdrop, it doesn't matter. I picked this red sparkly stuff because it was there and it was different. Okay, this sprite right here, this is the code that you're going to use, and when it runs you should see this result where our soccer ball, excuse me, our ball just moves in a square pattern. Okay, we have the sprite facing 90 degrees. If you look at the code right here, it's facing -180. That's because that was the direction it was facing last. Okay, we didn't reset that. However, if I click on the green flag, you'll notice it turns to 90 degrees, then it goes to 0 as it goes up, then -90, then back down to 180. And I could probably click on play and stop it. There we go. So you can see where it's at 90 degrees. That's happening right here. And what it's doing is it starts off of this -150, -100 XY coordinates, and then it's repeating this first block right here, going 30 loops for 10 steps to the right, which is 300 units. And then it points 0 degrees. I'll play it and pause it in time. Boom, right there. So we're at 0 degrees. So this piece of code is executing right now, and we're moving 10 steps per 20 loops right here. Or not per 20 loops, but it's repeating 20 times, 10 steps per loop, and it's moving upwards, which is going to be about 200 units total. And then it's going to face -90 degrees. Let me start it over and see if I can got it. So we're right here at -90 degrees. That's this piece of code right here. Then it's repeating 30 times at 10 steps. And let me start it over, run it, and when it goes down I'll stop it. Got it. It's at -180, and you can see this is where the piece of code started right here, where it was repeating 20 times, going down 200 units. And if you do the calculations, you'll notice it goes 300 to the right, 200 up, 300 back to the left, and 200 down. It completes a perfect square just by doing those calculations. Your program should do something similar. While you're experimenting with this, go ahead and play around with the different rotation styles and see if you can notice some differences on the sprite whenever it runs.